no worries.
Oh, yeah, that was probably a good idea. Okay, so I hope that, yeah, just as a quick reminder, these are the right angle formulas. When you have a right angle triangle and you know any two things about it, angle, side, 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 etc., you can use one of these rules. The question is which one you have to use. To figure that out, you need to set up the triangle properly, so you need to label the sides. If this is your angle of interest, we call this the adjacent side, this the opposite side, this the hypotenuse side. According to which sides you know or which one you're trying to find, etc., you will use one of these three formulas. We do not call this the sine rule. This is not the sine rule. It is a right angle triangle formula that contains the sine ratio. This guy is just an operator. What is the sine rule? The sine rule, the use case of the sine rule is this basically. Now, sine rule will work for any triangle, not specifically right angle triangles. So that already opens up a lot of doors for us. But we need a specific setup to be able to use the sine rule. What is that setup? Here I'm going to introduce the naming convention. What do I mean? Like, how do we name sides and corners? For example, if we call this corner A or this angle A, we will call its opposite side small a. Similarly, if we call this angle B, we will call the opposite side small b. And if this is angle C, then the opposite side is called small c. This is not just me choosing to do this, this is convention. We do this always, okay? So when I say A and then small a, what I mean is angle A and its corresponding side A, okay? So this small letter always corresponds to side, this always corresponds to angle, and the same letter means that they're corresponding things, meaning they're opposite parts of a triangle. Anyways, this is basically me explaining the background information you need to know for the sine rule. But now let's talk about how to use the sine rule. So what kind of situation can we use the sine rule in? So I'm essentially going to say that this is a pair, right? Angle side, the corresponding angle versus the corresponding side. This is a pair of information, right? If you know one full pair, meaning you know any angle and you know its corresponding side, and you know any one other thing. For example, you know an angle, but you don't know the corresponding side. So one full pair and one half pair essentially. You can find the missing part by using the sine rule. That's the idea. So what do I and but what's the formula? What's the sine rule actually? The mathematical definition? It's essentially that the sine of any angle in a triangle is always, sorry, the sine of any angle in a triangle divided by its corresponding side. This ratio is the same for all sides and all angles. So this is the sine rule itself. Now, why is this called the sine rule? Because it only uses the sine ratio. It's just like, a guy was sitting around, he was like, okay, this is a thing that happens. And then he said, oh, look, every part of this equation has a sine in it. So why not call it the sine rule? It does
Wait,
not, uh-huh.
I don't think that's right.
Oh, yeah, so you are gonna say that it's this way, isn't it?
Does it matter?
No, because I mean,
Okay.
if I say 1 over 2 is 1 over 2, and if I say 2 over 1 is 2 over 1, either way, it's true, right?
Yeah.
So
But
if you flip,
that one
uh,
isn't right because you
are you,
wrote B and a C.
oh yeah, Sophia, all right, it's not right. Yes, all right, yeah. So you can write it both ways. When you start to, by the way, the reason both of these are right is because if you flip all the fractions, then you've really done nothing. Because algebra allows
Mm.
you to do anything you want if you do it to everything. So since you did it to everything, you're fine. It's legal. Um, what was I gonna say? What was I gonna say? I was about to say something, and then I started talking about legal stuff in algebra. I was gonna say that. Okay. So which one should you use? That's a common question that pops up in a student's head, but they don't ask it because they think it might be a stupid question. Um, once you get enough practice, you'll start to notice that sometimes one of them is easier to use because it just helps you kind of solve the question a bit easier. But it absolutely does not matter. You can use either one. You will not go wrong as long as you don't, do what I did and put C here and B here. Okay. Thank you, Sophia, again for that. So let me show you guys an example of how this works quickly. Matter of fact, let me show you guys the question that I gave you for this question, for this rule. So I'm assuming that you guys didn't have time to check the answers for this, but let's
Why
look
did
at
you
this.
check the answers, by the way?
It's a very good question. I just realized I never told you guys where to check the answers. That's on me. I'll send you guys the link basically, and over there there's the matter of fact, let me show you now before I forget. So first of all, how do I know this is sine rule? Because I have one full pair. See, I know an angle and I know its corresponding side, so that's one full pair. And I know one other thing. So one full pair and anything else means I have to use a sine rule. Is that clear, the one full pair situation that I'm talking about?
Mm-hmm.
Okay, so now the sine rule says that the sine of an angle divided by its corresponding side, this thing, if I set it up for any pair, essentially, it'll be the same, it'll be equal. So for instance, if I know 7 centimeters and I don't know the missing angle, which is by the way what they're asking me to find, PRQ, right? Let's call it R for now. Don't call it small r. Small r is reserved for this guy. Okay? Sides are small r's. So sine of the missing angle divided by the corresponding side. So do you guys see how I set this up?
Yeah.
Yeah. So this pair and this pair essentially, and I set it up like this for each. And now I just need to solve this for r. First thing I should do is multiply both sides by 7. And then the other thing I should do is just take the sine inverse on the of all of this. And that is my answer. So let me see what it becomes. Sine inverse of 7 times sine 75 divided by, oops, divided by 10. That is 42.5 degrees. Is this clear now?
Mhm.
All right.
I need to ask about it
Yeah, go for it.
because this is the one I think I struggled with, and I
Hmm.
don't know why, but it's because in the formula booklet that you
Okay.
get, it's the other way around. So I was
Yeah.
doing like
So you
10
you
over
can,
the
yeah.
other.
So because again, algebra doesn't mind it when you flip both sides of an equation, right?
Mm,
So it's equivalent because
yeah.
algebra is communist essentially. It loves it when everybody gets the same thing, same treatment. So if you give the same treatment to both sides of the equation, it's the same exact idea, right? That's why I don't say that sine A over A. I say the ratio between the sine of an angle and its side. The ratio, you can flip it. Doesn't matter. 2:1 is the same as 1:2. I mean, not exactly, but you get the point. So you can write it both ways. But the reason that I instinctively chose to do it this way is because the thing I'm trying to find is at the top. It's extra annoying when the thing you're trying to find is at the bottom. Now you have to move more stuff around. So that you know how I said earlier that after you do a lot of practice, you're going to realize that one of these is a bit more useful in certain cases. That is because the thing you're trying to find, if you put it at the top, see how I just had to make one little movement. But now watch what I
Mm,
have to do. I'll have to cross multiply first, and then I have to divide by 10, and watch the fact that it's the same exact thing as before, right?
mhm.
But it's
Yeah.
just that I'm lazy. I don't like doing this extra step, so I put my R at the top. But again, it does not matter.
Okay.
Okay, answer is the same. So if this is the only thing that was confusing you, then the damage is much less significant than I thought. This is just a
Okay.
little, yeah, it's just a misconception. A lot of people have this, in
Yeah.
fact, so
And
no big
then
worry.
another thing is like I don't think I'm aware when to use the sign negative one.
Ah, okay.
And like yeah.
So it's essentially the thing is whenever the thing you are trying to find is stuck inside of a sign, you have to remove that sign by sign inversing.
Mm,
Okay. So for instance, if this was no, or like I don't know, x times sine of 10 equals 5, the thing I'm trying to find is sitting alone. He's untouched. He's not trapped in anything. So I
mm,
just have to remove this guy from here, and he's just a number. This guy's there's something weird. So I'll just divide both sides by sine 10. That's it. But if the thing I'm trying to find is like trapped inside of a sign, the only way to remove a sign, like detach a sign from here, is to take sine inverse. So that's the only thing you need to know about when to use sine inverse. When the thing you're trying to find is trapped inside a sine or a cosine or a tangent, you have to use the inverse of that.
mm.
Is that clear?
So basically when it's like an X or an R or an A, like
If it's an, well, what? I don't get it.
No, because you said that if it's a number, then it's like it's okay. You don't have to
Uh,
pick the inverse.
yeah, because it like essentially if the unknown, if the variable, if the thing you're trying to calculate is inside the sign. If it's outside the sign, you don't need to worry about sine inverses at all. But if the thing you're trying to find, like in this case, the r that you're trying to find is
Mm,
trapped inside a sign, right? The
yeah.
only way to remove this sign from here is to sine inverse. Essentially, think about it like this. If you have x squared equals 100, to remove the square from here, we cannot divide by 2. That's not how squares work. We have to do something special. We have to pull out the big guns, a different kind of gun, I guess, at least from our normal algebra strolls in the park where we divide or multiply or subtract or add things to both sides. To remove a square is a special operator. We have to bring in another special operator, which is the opposite of a square, which
Mm,
cancels out the square. Okay? Similarly, if the thing you're trying to find is trapped inside of a sign, we cannot divide by sign. That doesn't make any sense. Okay, so what we have to
mm,
do is bring out the big guns. We have to do something that removes the sign. The only thing that removes the sign is the sine inverse. That's why we do that to both sides in this case, just like we did square root to both sides in that case. Okay,
yeah.
because sine inverse cancels out the sign and out comes my x. He's now no longer trapped inside of a sign. Is that clear?
Yes.
Okay. And also a general note, I mean, honestly, you shouldn't need this because this idea that I've explained is pretty self-contained. But in general, if you're ever trying to find an angle, you will most definitely will need to use a inverse of some kind, of a trigonometric inverse. Whenever you're looking for an angle, expect a sine or cosine or tangent inverse in your problem. Whenever you need an angle, because angles normally come inside of sines or cosines or tangents, right? See,
Mm,
in all the rules we have, the angle part is trapped inside the sine always. So if you ever have to find the angle, best bet that you're going to want to remove the sine or cosine or tangent from here. And the only way to do that is using the inverse part.
mm,
Okay, so that's basically it from here. Now about the area, I don't know if you guys tried this out because I didn't tell you guys the area formula using trigonometry. But it's pretty simple. It's also in your formula booklet. Whenever you have a triangle, and you know an angle, like for instance, in this case, you know 75 degrees. You also know R now, you 42.5 degrees. Which sides do you know? 10 and 7, right? So first of all, I'm gonna give you guys the rundown of how to find the area using the formula I'm about to tell you. Area of a triangle. This is gonna be a funky formula. It's not specifically for right angle triangles, you know, the 1/2 base height that you guys are familiar with. Essentially, if in any triangle you know an angle and you know the two sides around it, you can use this formula. Okay? So sine of two sides times, sorry, 1/2 times side A side times side B times sine of the missing side's angle. Okay? So I like to just kind of remember it like this. Two sides and angle between them, use this formula. Okay? So in this case, we know these two sides, but we do not know the angle between them. You guys watch Vsauce. Do you know Vsauce, the guy, the bald guy?
No.
no.
Damn, wow, he's can't be that old. Anyways, so he has a thing where he goes, or do we? Anyways, so we know the two sides. We don't know the angle between them. We can find the angle between them, can't we?
Yeah.
How?
Just take 180 minus the angles we know.
Because the total angle inside of a triangle is 180, so we can find this guy by doing 180 minus whatever is the other angles. So minus 75 minus 42.5, which tells us that this angle is 62.5. And perfectly, we know the exact situation, or we have this exact situation that we need to find the area using this formula. We know two sides and the angle between them. So the area is simply going to be 1/2 times 7 times 10 times the sine of 62.5. That's it. Is this clear?
Yeah.
Yes.
Okay. So that's the sine rule. Let's do a recap of the cosine rule now, which was the first question I gave you guys. So The cosine, so or similar to the sine rule, my method of teaching the cosine rule is I teach you the case that you're looking out for the cosine rule. Okay, what's the case for the sine rule? If you know one full pair and one half pair, you can find the missing part of that half pair by using the sine rule. Okay, that's the idea. For the cosine rule, there are two cases. Case number one is when you have, I don't know why, but I like to call it the scissor case, when you know two sides and an angle between them. Okay. By the way, let me tell you guys what the cosine rule is first. So, for example, if this is A, this is B, and this is C, this is small a, this is small b, and this is small c. The cosine rule simply says that this is an equation that connects the sides and the angles of this triangle. So basically, so this side squared equals the other two sides squared and added, minus 2 times, again, the same sides, right? Times cosine of the angle A. Now, the most important thing is to not mess this up. Whatever side you pick as your subject needs to be like, its corresponding angle needs to be over here. Do not put A here and angle B here, okay? I will be in your nightmares if you do that. It's like the worst, the only mistake you can make with the cosine rule. Okay, the side you put here, put its corresponding angle over there. Do not mess this up. Okay, that's the only thing I ask of you for the cosine rule. Now let's look at the two cases. Okay, case number one is the scissor case by Minhal. So essentially, if you have if you have a triangle, and for instance, you know that this is 2 and this is 5, and you know the angle between them. So like, I don't know, 30 degrees. See? Scissors. They look like a pair of scissors, I guess. Anyways, so you know the two sides and the angle between them. That is the first case. You can find this missing side by using the formula. Okay? Now, a lot of students get caught up trying to match the letters to the, to the sides. I don't like that. Simply do it this way. Which side should be your subject, first of all? You should always pick the side to be the subject whose angle you know, okay? Because otherwise, when you put the side here, you won't know what the angle is here. So if you know the corresponding angle of a side, make that the subject, okay? So I will make x squared the subject. And then just square the other two sides and add them up, minus 2 times the other two sides, times cosine of the corresponding angle of that subject side, 30 degrees. And that's the formula, that's it. Okay, so x squared equals 2 plus 5 squared, 2 squared plus 5 squared, minus, again, 2 times 5, see, 2bc, times cosine of the missing angle. The reason this is called the cosine rule is, well, because there's a cosine in it. There's no other reason. You can kind of solve this equation to find the missing side, and that's the idea. Okay, is this clear?
Yeah.
Perfect.
Can
The
I
other,
ask something?
yeah, go for it.
When is the case where you need to use cosine inverse?
Great question. So, do you think we need to use cosine inverse in this case?
No.
No, because we already know the angle. So if you don't know the angle, that's when you need the cosine inverse. But when do we need the cosine inverse? Right? I mean, if the thing you're trying to find is not an angle, forget about cosine inverse or any inverse. If you're looking for an angle, that's the only case where you will definitely have a cosine, sine, tangent inverse happening. Let me show you guys the other case, and then Sophia's question will make more sense. So the other case is all sides known. So if you know oh God. If you know all three sides of a triangle, do not think about anything. I mean, of course, think about the cosine rule, but don't think about anything else, okay? So if you know all three sides, I mean, that's the easiest thing to remember, honestly. But the problem is I need to make sure I don't pick bad sides. Let me just quickly do a thing to figure out a good triangle to use here. Times cosine of 120, square root. Okay, I'm going to use a very specific number. So let's say you have 7, you have 9, and then you have like 13.9. Okay, so because I can't just randomly pick the third side. Triangles don't really, they can't just exist with any side length. And so you know all three sides in this case, don't you? Let's say you're trying to find this angle. Okay, let's call it theta. Now, If you know all three sides, you can find any angle you want. Let's say I want to find this one. I want to ask you guys a question, not Sophia because she knows already. Jessica or Amy, which side should be the subject of my equation in this case, if I'm trying to find this angle?
Is it not the 13.9?
Amy, what do you think?
Yeah, 13.9.
Yeah, because again, these come in a pair. The cosine rule, if I use this side, I will have to use that angle and vice versa. Sophia, right? Makes sense?
Mhm.
Yeah. So let's make 13.9 the subject equals 7 square plus 9 square minus 2 times 7 times 9 times cosine of the missing angle. Now, do you see why I need the cosine inverse in this case? The thing I'm trying to find is trapped inside of a cosine, or
Mm.
I'm looking for an angle. If you're looking for an angle, you always need some kind of inverse, because angles always come trapped inside a trigonometric ratio. So let's solve this equation now. So I'm trying to make cosine theta the subject first, or you're AISL students, you can just write all of this down in your calculator and just do n solve and get it over with. But if you wanted to do it by hand, you're trying to make cosine theta the subject, so you need to subtract this and this from the left side first. So 13.9 squared minus 7 squared minus 9 squared. And then you see a minus 2 times 7 times 9, so let's divide it by minus 2 times 7 times 9. There. So cosine theta is left alone in one clean step. Finally, to find theta, again, theta is trapped inside a cosine, so I need to take cosine inverse on both sides to remove this cosine from here. Cosine inverse of all of that mess. I highly suggest that you guys calculate this, this basically first, and don't write the whole thing in the calculator in one go, because you are prone to making mistakes if you write such a big expression in a calculator.
There
So
is
that
there is no need for the 2 to be negative.
um there is actually.
No.
There is, yeah, because okay, I think what you're telling me is that so you're getting confused about the fact that normally there is no minus here because we can apply the minus at the top and make, flip the signs of everything at the top instead and remove that minus from the bottom. This is
Mm-hmm.
true. I could have done that, but I didn't want to kind of do that extra step
Mm.
again because I'm pretty lazy. But the real reason I didn't want to do it is because I wanted you guys to see that clearly I brought this to the left side, the whole thing with the minus. Okay. But yeah, either way, you can plug either one of these in your calculator and get the answer from this. And that's basically the only other case of cosine rule. And actually, this is all of the possible trigonometric questions you can get in an exam. You will not be expected to know anything else about trigonometry. Of course, other than the very basic ideas like the total, the sum of the internal angles is 180. Uh, and you're also supposed to know the Pythagoras theorem, of course. Everybody should know that.
Another thing about the Pythagoras theorem that I had a question about today in
Okay.
my mind is like, is it only applicable to right angle triangles?
Yep.
Okay.
Pythagoras, he was a very smart guy, but I don't know like how smart he was. But essentially he said that if you have to move in this direction and then in this direction, then the shortest path you can take is the straight path, and we call this the hypotenuse. Of course, the poor guy, he said something much more complex, but I'm kind of simplifying it a lot for you guys. But yeah, it requires a right angle triangle. Okay.
Mm.
A very weird common mistake I've seen people doing is this one, where the Pythagoras theorem goes like this, right? A square plus b square is c square.
Mm-hmm.
They mix it up. They say a square plus c square is b square for some reason. Remember, the hypotenuse is supposed to be on the right side, okay? Add the other two sides equals the hypotenuse, okay? Don't mix it up. You see what I mean?
Mm-hmm.
Yeah. So, yeah. Um, Nothing else comes to my head, like, without looking at questions. But these
It's
are
not possible for tangent to be on the exam.
uh tangent, as in this guy?
Yeah.
Do you mean this?
Or is it only for like calculus?
No, no, no. Tangent. Oh, there is no tangent rule. There's no
No,
such
no,
thing
no.
as a.
I know that, but do they ever ask about it on the exams? Because I haven't seen it.
You mean about the tangent ratio or like tangents, like the graphical tangents?
No, in trigonometry.
I mean, yeah, sure. They might give you a right angle triangle where they give you O and A, and they will expect you to use the tangent formula in the right angle triangle formulas.
Mm.
Why not? Yeah. But again, remember that SOHCAHTOA, sine rule and cosine rule, these are three different mathematical formulas or rules. They do not have any kind of overlap, okay? They have no like relation to each other. Okay? So they do use similar trigonometric operators like sine, cosine, tangent, but they belong to three different cases, three different situations. Well, the first one is only for right angle triangles, the second one is for like this pair situation, and the cosine rule is for these two specific situations. And that's basically an overview of every bit of trigonometry you need for AISL essentially. I think we can stop recording this part now.